Hi everyone, I'm Nandana PP and today I will be presenting on history of AI representational schemes. In this presentation, I will take you through how artificial intelligence has evolved in the way it represents and stores knowledge from the early days of symbolic logic, where knowledge was expressed through rules and symbols, to today's advanced neural and hybrid models, which can learn and reason almost like humans. Understanding how knowledge is represented is essential because it forms the foundation of all AI systems. It's what allows machine to think, learn, and make decisions intelligently. Let's begin by understanding what actually mean by knowledge representation. Knowledge representation or care is how AI systems store and use knowledge about the world. It's the bridge between human understanding and computer reasoning. In simple terms, it allows machine to think, to use stored knowledge to make logical decisions. For example, an AI in healthcare uses stored knowledge about diseases and symptoms to suggest a diagnosis. Knowledge representation is important because it helps AI reason, learn, and solve problems. It provides structure to information, remove ambiguity, and allows AI system to make logical inference. It allows sharing knowledge between different systems. For example, two robots can understand each other if they use common representation. In the 1950s and 60s, AI started with symbolic logic using formal symbols and mathematical rules. There were two main types: propositional logic for simple true or false statements, predicate logic for representing relationship like John loves Mary. These systems could reason very preciously, but they were not flexible. They couldn't deal well with the uncertainty or real world complexity. In the 1970s, a scientists want a more human-like way to store knowledge. They introduced the semantic networks where knowledge is stored as nodes and links, like a web of connected concepts. For example, dog is an animal or dog has tail. Then came frames created by Marvin Minsky which act like templates for typical situations like a restaurant frame that stores information about the waiter, menu, and customer. This method helps the AI understand concept and relates better. During the 1980s, expert systems became popular and production tools were introduced. These are simple if-then statements like if fever and cough, then flu. Such systems could imitate human experts, for example, in medical diagnosis. At the same time, scripts were developed to represent typical sequences of events like going to doctor or attending class. Together, they help the AI understand how events unfold in real life. In the 1990s, focus shifted to ontologies and knowledge bases. Ontologies gave a structured vocabulary like defining what animal, mammal, and bird mean and how they are related. Knowledge bases stores this information for reasoning. A famous example is the CYC project, which tried to capture human knowledge in the computer readable form. This era made AI systems more organized and shareable. As AI started facing real world uncertainty, purely logical systems weren't enough. So, in the 2000, probabilistic and statistic method became popular. Bayesian network represent uncertain relationships, like how weather affects carrying an umbrella. Hidden Markov models were used in speech recognition and language processing. These models allowed AI to make decisions even when data was incomplete or noisy, a big step towards realistic AI. The 2010s brought a major change. Deep learning and neural networks. Instead of manually coding rules, AI began learning from data. Knowledge was represented as numerical vectors, knowledge as embeddings. Models like Word2Vec, VVRT, and GPT learned the meanings of word and patterns automatically. This made AI extremely powerful in understanding speech, text, and images, though it became harder to interpret how exactly the system thought. Today, the trend is hybrid AI or neurosymbolic AI, which combines the best of both worlds, the reasoning power of symbolic AI and the learning power of neural networks. For example, deep learning models can extract information while logical systems reason about it. This makes a smarter, more explainable, and capable of solving complex real world problems like autonomous driving, healthcare, and robotics. To conclude, knowledge representation is truly the foundation of artificial intelligence. It defines how machines store, process, and reason with knowledge, much like how humans think and learn. Over time, we have seen a major evolution from symbolic logic in the 1950s, which focused on strict rules, to semantic networks and frames that brought context, then production rules and scripts powering export systems, and later ontologies and knowledge bases that help organize knowledge. The 2000s introduced probabilistic models to handle uncertainty, and today we have neural and hybrid AI combining learning with reasoning. Each stage made AI more intelligent, adaptable, and closer to human-like understanding. This journey of representational schemes shows how AI has grown from simple logical system to complex learning-based models capable of tackling real-world problems with reasoning and intelligence. Thank you everyone for listening so patiently. I hope this presentation helped you to understand how AI representational schemes have evolved through time. Thank you once again for your attention and support.